Good morning, guys. So we are going to move into section 9.4, which is law of cosines. This is basically just another formula that we have available to help solve oblique triangles. So it fills in the gaps for the situations that the law of sines would not satisfy. So first off, here we have our equations. Now, all of these are essentially the exact same equation. Keep in mind, this is all going to reference some oblique triangle ABC. So all of these lowercase letters, a squared, b squared, c squared, these are all going to be side lengths for this triangle. And the capital A, B, C you see inside of your cosine, those would be an angle. So if you notice, it kind of looks like a Pythagorean theorem. And in fact, the case where the angle of reference is a 90-degree angle, just think, what's cosine of 90 degrees? Well, that comes out to be 0, so then this whole term would drop out, and you're left with exactly what the Pythagorean theorem would be. So what we have instead is a more powerful formula for the Pythagorean. We call it the law of cosines. For the record, when using this, you're essentially always going to be solving for either the side length that is isolated on the left side, or you're going to be solving for the angle inside of the cosines. So let's see a couple of examples of this at work. So I have a triangle, a side angle side triangle, meaning I have two sides and the included angle in between them provided. So that's going to look like this triangle here. We have two side lengths, B and C, and angle A is 60 degrees. So the first thing we're going to do is notice that the angle A and side A are opposite. So anytime you have two sides and an included angle, you can solve for the opposite side. So we're going to plug in to our first line of the previous slide for A, and we have a squared equals b squared plus c squared minus 2bc cosine A. All right, again, this angle and this side are always opposite one another in the triangle, so you're going to look for that proper setup. And we're going to allow for a little bit of rounding, so we get about 26.5-ish units for side A. Now we can solve for angle B or C next using the same exact formula, but with respect to side B. If I'm solving for angle B inside of my cosine, I'm going to now find side B over here. Keep in mind, you don't have to use law of cosines at this point. You could be using law of sines instead. I don't really have a strong preference either way once you have enough information to use either one. But being that this is a law of cosines PowerPoint, we're going to get through using those. So we get down to cosine B equals this reduced fraction, which you're going to do inverse cosine, and there we go, faded away, 41 degrees. So we have two of the three angles. The third one you simply subtract from 180 and you get your third angle C. So that's the case with side angle side. Again, two sides in the included angle. Let's just see another situation that comes up with that. I'm actually going to go through this slide pretty quick because, again, it's a very repetitive setup here. So if you want to hit pause at any time, this is literally the same situation, just another example of side angle side, and using that to solve for any of our unknown side or unknown angles. For time's sake, I'm going to move on to our last setup, our last possible pieces of information would be side, side, side. So three side lengths would be given to you, not a single angle. So obviously law of sines would fail here because you don't have any angle to set up a ratio. So what we do instead is we use law of cosines, and we're going to use that to solve for one of the angles. Okay? Now, this is very important. This is not the ambiguous case important, but it is the one quote unquote trap with the law of cosines. With side, 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 you have to use law of cosines. Specifically, though, you want to solve for the largest angle first, which is going to be opposite the largest side. All right. And the reason being, well, let's actually get into this in a quick second. So we're going to set this up to solve for angle B first. Now, we set up with b squared equals a squared plus c squared minus 2ac cosine b, right? So we're going to subtract the 6 squared, the 4 squared over, and we're going to then divide by the negative 48. Keep in mind, this is a coefficient in front of cosine, so we can't add or subtract just this number. All right, what we can do is divide it by that. So here's why solving for the largest angle first is so important. All right, cosine b equals this negative number, okay? Immediately, I know when I use inverse cosine, angle B is going to be in quadrant 2 because the cosine ratio is negative, which means angle B is obtuse. It's 127 degrees to be exact. If you didn't solve for the largest angle first, let's say we solved for angle A or angle C instead, and then we switch into law of sines. As I suspect, many students are going to prefer law of sines, which is fine, but sine inverse doesn't go into quadrant 2. Sine inverse will never output an obtuse angle. So you're going to get the wrong angle. You're going to get the corresponding quadrant 1 ratio instead. So just be aware of that limitation on this. If you're just consistent with, let me solve for the largest angle first, and then the next one, and then the smallest one, you're going to be cautiously in a good spot. So now we can continue. We're going to solve for angle A next. That would be the middle size angle. And you could use law of sines at this point because we know we found our obtuse angle. There's not going to be a second obtuse angle. Or you can continue with law of cosines. So I'm going to map through this. Again, subtract the 9 squared, subtract the 4 squared, but we're going to divide by the coefficient in front of cosine, and cosine inverse of a positive ratio would give me 32 degrees. Once you have two angles, it's easy enough to find the third just through subtraction. Okay? Again, the only word of caution, and it's a pretty strong word of caution I'm going to note, is with side, 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 you must solve for the largest angle first. So let's do just another quick example of that. A little bit faster, I'm going to click through this. So with triangle ABC, where the largest side is B, then we need to set up solving angle B first. And again, we're going to set b squared equals a squared plus c squared minus 2 ac, cosine b. Subtract, divide your coefficient, and use a cosine inverse. Again, notice that the cosine ratio is a -1 here. So we're going to have a obtuse angle because cosine inverse of something that's negative is going to go into quadrant 2. Again, we wouldn't see that with a sine function. So once you have one angle, you can again set up a different formula. Again, you can use law of sines, law of cosines once you have a angle in side, side, side. Going through and setting up an equivalent formula for angle A, solving using cosine inverse gets us 52 degrees, and then very quickly we can subtract and get 30 degrees. Okay, so what we see here is law of cosines doesn't have an ambiguous case, which is good news because you're only going to ever have one triangle possible. The bad news is the trap that occurs is with side, side, side. And as long as you approach it in the correct order, you're going to be fine. So take a look at the homework and pacing guide. The homework's already listed on there. Go ahead and get started with this. And Monday, we're going to continue a little bit more with law of cosines and some other applications in section 9.4. Good luck. Enjoy your weekends.